Postgres indexes are the thing everyone adds and almost nobody actually pictures. Your query is slow. Someone says add an index, you add one. Sometimes it gets fast. Sometimes nothing changes and you have no idea why. That gap between adding an index and understanding it is what this video closes. There is one picture that makes all of it obvious, and once you have it, explain stops being scary. Here is the whole idea in one sentence. An index is a sorted side table of one column where every entry points back to the full row. That's it. That's the mental model. The index is a phone book. Think about an actual phone book. The names are sorted. Each name has a number next to it that tells you where to find the person. The phone book is not the people. It's a sorted lookup that points at them. Our Postgres index is exactly that. When you index the email column, Postgres builds a separate structure where every email is kept in sorted order, and next to each email is a pointer to the row it came from. So now you have two things. You have the table sitting on disk in basically the order rows were inserted, unsorted for our purposes. And you have the index, the same emails, sorted, each one holding a little arrow back to its row. Why does sorting matter so much? Because of how you search. Without an index, finding one email means Postgres reads the table from the top and checks every single row until it finds a match. Every row. That's called a sequential scan. On 1,000 rows, it's instant. On 50 million rows, it's the spinning loader your users are staring at. With the index, Postgres doesn't read the table looking for the email. It searches the sorted phone book instead. And searching something sorted is the fastest kind of search there is. You jump to the middle, decide left or right, and throw away half the data with every step. 50 million rows takes about 26 steps, not 26 million. 26. The structure Postgres actually uses for that sorted phone book is called a B tree. You don't need the internals. Just hold the picture, a sorted thing you can search by having, where each entry points back to a row. You don't have to take my word for any of this, because Postgres will tell you exactly what it's doing. The tool is explain and is the most underused command in the language. Put explain analyze in front of any query and Postgres runs it and prints its plan. Before the index, you'll see the words Seq Scan, sequential scan, and a number like execution time, 400 milliseconds. That's it, reading the whole table. Now create the index. Create index on users, the email column. Run the exact same explain again. The plan changes. Now it says index scan and the execution time drops to something like 0.03 milliseconds. Same query, same data. You just gave it a phone book instead of making it read the whole table. That line, Seq Scan versus index scan, is the single most useful thing to look for in your whole career with Postgres. Seq Scan on a big table is the smell. Index scan is the fixed landing. Here's where most people get quietly burned, the composite index. An index on more than one column. Say you query by last name and first name together. So you build an index on both last name, then first name. Picture the phone book again, because the phone book already works this way. It's sorted by last name first, and then within each last name by first name. Smith Adam comes before Smith, Beth. That ordering is the entire point. An index on last name then first name is brilliant for find everyone named Smith and brilliant for find Smith Adam, but it is almost useless for find everyone named Adam, any last name, because first name is the tiebreaker, not the sort. All the Adams are scattered across the whole book, so the rule falls right out of the picture. In a composite, index order columns from the one you filter on most exactly to the one you filter on least. The leftmost column is the one Postgres can actually jump to. Get the order wrong and you built an index the planner won't even use. Which brings us to the most frustrating moment in databases. You added the index and Postgres ignored it. Seq Scan, still slow. 3 reasons, all explainable by the same phone book. 1. You wrap the column in a function. You indexed email, but your query where lua of email equals something. The phone book is sorted by email, not by lua of email, so Postgres can't use it. The fix is to index the exact expression you query, an index on lua of email. 2. The query returns most of the table anyway. If you're asking for 90% of the rows, jumping around the phone book and following 90% of the arrows back is slower than just reading the table start to finish. Postgres knows this, does the math, and correctly chooses the Seq scan. The index isn't broken, it's the wrong tool for a query that wants almost everything. 3. The table is tiny or the statistics are stale. On a few hundred rows, reading everything is genuinely faster than the index dance, so Postgres skips it. And if you just loaded a pile of data, run analyze, so the planner's estimate of the table matches reality, it decides using statistics, and still statistics make bad choices. One honest trade-off before the verdict, because indexes are not free. Every index is a second structure Postgres has to keep in sync. Every insert, every update, every delete on that table now also updates the phone book. So an index reads faster and writes slightly slower, and it takes disk space. That's the real decision. Index the columns you actually filter and join on. Don't index every column just in case. On a write-heavy table, a pile of unused indexes is pure tax. The boring answer is the right one. Index for the queries you really run, then check with explain. So here's the whole video in the picture you came for. An index is a sorted front book of a column, each entry pointing back to the row. Sorted means searchable by having, which is why it's fast. Composite indexes are sorted left to right, which is why column order decides everything. And Postgres ignores the index whenever the phone book doesn't match the question, a function on the column, a query that wants most of the table, or stats that don't reflect reality. Red one is plain plan with that picture in your head, and indexes will never feel like guesswork again. Look for Seq Scan versus index scan. That one line tells you almost everything. If this made indexes click, do me one real favor. Hit like and subscribe. It's genuinely what tells me to keep making these, and it's free to you. Next up, I'm taking the same one picture treatment to database transactions and the word everyone says and nobody defines. ACID, what isolation levels actually protect you from, shown on screen. Subscribe so you catch it. I'm Sensei. Go read a query plan.